Hello everyone, in this video we are going to see about semiconductors. First we see about introductions about semiconductor. A semiconductor can be considered as a material having a conductivity ranging between that of an insulator and a metal. A crucial property of semiconductor is the band gap, a range of forbidden energies within the electronic structure of the material. The semiconductor materials of the devices are silicon, germanium or gallium arsenide, which can be used as a rectifiers, oscillator, light emitters, amplifiers, photometer and other equipment. These are the semiconductor devices: op-amp, integrated circuit chip, transistors, diodes, capacitor and resistors. Let's see about properties of semiconductors. There are four important properties of semiconductors. The property 1, the resistivity of a semiconductor is less than an insulator but higher than a conductor. Then property 2, at 0 Kelvin, semiconductor behave as insulator. As the temperature is increased, it work as a conductor. And property 3, semiconductor shows a negative temperature coefficient of resistance. In simple words, the resistance of the semiconductor decreases the temperature. The property 4, the conductivity of the semiconductors increases when impurities are added. The process of adding impurities to semiconductor is called doping. Next we see about types of semiconductors. Semiconductors are devices that are neither conductor nor insulator. The conductivity of a semiconductor is changed by doping. There are mainly two types of semiconductor: intrinsic semiconductor and extrinsic semiconductor. First we see about intrinsic semiconductor. An intrinsic semiconductor, also called an undoped semiconductor or I-type semiconductors, is a pure semiconductor without any significant dopant species present. The number of charge carriers is therefore determined by the properties of the material itself instead of the amount of impurities. An intrinsic semiconductor is a semiconductor in which no other material is intentionally doped, similar to mixing, for example, silicon germanium. Next, extrinsic semiconductor. Extrinsic semiconductors that are doped with specific impurities. The impurity modify the electrical properties of the semiconductor and make it more suitable for electronic devices such as diodes and transistors. The example of extrinsic semiconductor are pure silicon and germanium doped with chemical impurities like arsenic, boron, etc. These are the different types of semiconductors: extrinsic semiconductor, intrinsic semiconductor. Related images. An extrinsic semiconductor is divided into two types: N-type semiconductors and P-type semiconductor. An N-type semiconductor is doped with phosphorus, arsenic and antimony as an impurity. Silicon of group 4 has 4 valence electrons and phosphorus of group 5 has 5 valence electrons. Then see about properties of N-type semiconductor. It is an extrinsic semiconductor which is obtained by doping the impurities pentavalent impurity atom such as antimony, phosphorus, arsenic, etc. to the pure germanium or silicon semiconductor. The impurity atom added provide extra electron in the structure and are called donor atom. The electrons are majority charge carrier and holes are minority carrier. Then P-type semiconductor. A P-type semiconductor is formed by adding third group elements such as boron and aluminium as a doping element. An impurity added creates a vacancy of electron. In P-type semiconductors, holes are the majority carrier and electrons are the minority carrier. Then properties of P-type semiconductor. It is extrinsic semiconductor which is obtained by doping trivalent impurity atoms such as boron, gallium, indium, etc. to the pure germanium or silicon semiconductor. The impurity atom added create vacancies of electron in the structure and are called acceptor atom. The holes are majority charge carrier and electrons are minority carriers in P-type semiconductor. Then see about difference between intrinsic and extrinsic semiconductor. An intrinsic semiconductor is pure form is called as intrinsic, and semiconductors which are doped with the impurities are called extrinsic semiconductor. Here the change carriers are produced only due to thermal agitations. Here the carriers are produced due to may not also be produced due to thermal agitation, and they have low electrical conductivity, they have high electrical conductivity. In intrinsic semiconductor they have low operating temperature. In extrinsic semiconductor they have high operating temperature. In intrinsic semiconductor at 0 Kelvin, Fermi level exactly lies between conduction band and the valence band. In extrinsic semiconductor at 0 Kelvin, Fermi level exactly lies closely to conduction band and N-type semiconductor and lies near valence band in P-type semiconductor. The examples of intrinsic semiconductors are silicon, germanium, etc. For extrinsic semiconductors are silicon and germanium doped with aluminum, polonium, arsenic, etc. Then, semiconductor elements in the periodic table. In group 3, there are boron, aluminum, gallium and indium. In group 4, carbon, silicon, germanium and tin. In group 5, nitrogen, phosphorus, arsenic and antimony. Then, compound semiconductors. Compound semiconductors are designed by the chemical combination of two different elements. Compound semiconductors are normally designed by using elements from group 3 and 5 of the periodic table. Few examples of compound semiconductors are gallium arsenide, silicon carbide, etc. In organic semiconductors contain polymer structures normally composed of carbon or hydrogen. The first organic semiconductor discovered was bench-gar salt in 1980. Then liquid or amorphous semiconductor. Normally semiconductors are available in solid state, but few liquid or amorphous semiconductors are also discovered. That implies hydrogenated amorphous silicon. Few oxides and alloys also depict semiconductor behavior. Then application of semiconductor rectifier. Change AC voltage to DC voltage. A half wave rectifier allows current to flow during half the AC cycle. A full wave rectifier rectifies both halves of the AC cycle. The second one, integrated circuit. A collection of interconnected transistor, diodes, resistor and capacitor. Then automotive, alternator, regulator, ignition, stereotype and entertainment. Power supplies, stereo, radio and television. In appliances, drill motors, blenders, mixers, air conditioners and heaters. Then uses of semiconductors in everyday life. Temperature sensors are made with semiconductor devices. They are used in 3D printing machines and used in microchips and self-driving cars and used in calculators, solar plates, computers and other electronic devices. And transistors are MOSFET used as a switch in electrical circuit are manufactured using semiconductors. Conclusion. Semiconductor devices have a wide range of current and voltage handling capabilities. With current rating from a few nanoampere, semiconductor devices lead themselves of integration into complex but readily manufacturable microelectronic circuits. The development of power semiconductor is very essential. Thank you.